All right, in this lesson we are looking at rational expressions. Okay, so have your notes printed out. And first I go through the definition of what a rational expression is, but when you see the word rational, you think fraction. So we're going to work through our examples. So the first ones are evaluate the following rational functions for the given value. So if I give you a rational function, f of x equals x squared minus 25 over x plus 5, and I say find f of 0, all I'm doing is asking you to plug in the 0 for x. And remember, every time you plug in a number, you put it in parentheses. So on the top, I get negative 25, and on the bottom, I get 5. And if I simplify that, I get just negative 5. Okay. All right, so let's do negative 2. So again, everywhere I have an x, I plug in whatever that number is. So it's negative 2 in this case. So on top, negative 2 squared is 4. 4 minus 25 over, all right, negative 2 plus 5 would be 3. So that's 21 over 3, which is, oh, no, negative 21 over 3, which is negative 7. All right, now look at this one. When I plug in the negative 5 squared, on top I get 25 minus 25, but what do I immediately get on bottom? And I'm sorry, I don't know why that parenthesis is there. Okay, on bottom I get a 0. Once I get a 0 on the bottom, I can stop, because remember in math, your number one rule is you can't divide by 0, so you can't do that. So this one would be a no solution. All right, let's look at our next set of examples. All right, this one talks about domain. This is something you'll talk about in college algebra in great detail. We just talk a little bit about domain restrictions here, okay? But you can see it highlighted. Okay, to find domain restrictions, you set the denominator not equal to 0 and solve it. So what you're trying to do is find me those numbers, like in that example we just saw, that get me a 0 on the bottom. Okay, find me the numbers that get me into trouble. So don't worry about the top. To find a domain restriction, you write the bottom not equal to 0 and you solve it. Not equal and equal solve the same way, so here I'm adding 1 to both sides. So x can't be a positive 1. So again, what you're looking for is you're saying, hey, what number can I plug in for x and turn the bottom into 0? And you can see if you plugged in 1, what do you get on bottom? 0. So that's your domain restriction. If you got one like this, anytime you got an x squared, that means there are 2 of them. So what you would do is set the bottom not equal to 0, and you would factor it. So it's an easy trinomial. Well, multiplies for 6 and subtracts for 1. That's going to be 2 and 3. And they get opposite signs because you circled a minus, so I want a minus 3 plus 2. And then this works just like our previous lesson. You set each one, in this case, not equal to 0, but you solve it. So this one has 2 domain restrictions, and they are, if I plug in a negative 2, I get a 0 on the bottom, and also if I plug in a 3, I get a 0 on the bottom. So domain restrictions are just what numbers do you plug in and turn the bottom into 0. So set the bottom not equal to 0 and find them out. Alright, so to simplify, okay, simplify, what you're going to do is factor the numerator and the denominator completely, and then cancel out any common factors. So we've got this one. What you're going to do is draw me a blank fraction. You'll factor the top, factor the bottom. So on top, remember when you factor, first thing you look for is GCF. I can take out a 5, and I'd be left with x plus 5. And on bottom, how do you factor x squared minus 25? Good. Difference of squares, x plus 5, x minus 5. So you'll factor it, and if they share anything in common, what you'll do is knock them out. So your answer is what's left on top over what's left on bottom. I don't want you to get tempted to knock out the 5s. I usually get the question of, do I have to have those parentheses in the bottom? No, you don't. But if you leave them in, you're not quite as tempted to try to reduce those 5s, which don't. Okay. All right, so same thing here. We're going to factor the top and factor the bottom. So the top, easy trinomial, what multiplies for 12 and subtracts for 4. That's going to be 6 and 2, and they get opposite signs, negative 6 plus 2. And on the bottom, what multiplies for 12 and adds for 8? Well, that's a 2 and a 4, and they get the same sign on the bottom, and so they're both match the middle. They're both positive. So in this case, what knocks out? Good. x plus 2's. So again, my answer is what's left on top over what's left on bottom. All right. So another one. All right. GCF on top, I can take out a 3. On bottom, can I take out anything? No. So if you can't take out anything, sometimes people like you to put parentheses around them. Okay. And does anything knock out? Nope. So you can just give me that. Or you can say it does not simplify, something like that. All right, if you're going to do multiply, so to multiply, what it says to do is factor each numerator and denominator and then cancel out any common factors. You can cancel out top and bottom and diagonally. All right, so when you see this multiply problem, you got the multiply in the middle, you're going to come underneath and make them blank fractions. We're going to factor everybody. So x squared minus 9 factors into x plus 3, x minus 3. At this point, you should be pretty quick at your factoring. All right, on the bottom, what multiplies for 6 and subtracts for 1? All right, that's going to be 2 and 3. And opposite signs, negative 3 plus 2. On the top, what multiplies for 6 and adds for 5? Well, that's going to be 2 and 3. And they get same sign and they're both positives. And on the bottom, what multiplies for 6 and subtracts for 1? Well, that is a 2 and a 3 again. And to get a positive 1, the 3 gets the positive. They get opposite signs. All right, so you get it all factored. And then what you can do is you can take 1 from the top with 1 from the bottom. So like these x minus 3's would cancel. Okay. These x plus 3's would cancel. Okay, and I can also cancel diagonally. So this x plus 2 would also cancel. It's 1 from the top and 1 from the bottom. So I'm left with an x plus 3 on the top and an x minus 2 on the bottom. All right, same thing here. Make a blank first and then let's fill them in. So remember GCF, always ask for it. So on the top, I could take out an x and I'd be left with x plus y. All right, on the bottom, this is just difference of squares. X plus y, x minus y. You might not have recognized it at first, but now you should see it. Right, on the top here, I can take out a 4, and then I'm just left with an x. All right, so let's cancel what we can. So the x plus y's are definitely gone, and the x minus y's are definitely gone. What else knocks out? Good, an x. So my answer is just a 4. These are designed to work out. You start with something ugly and you get something fairly pretty in the end. And then our last two are divide. So it works just like multiply, except for you have to remember to change divide to multiply and flip that second fraction around. So I'm going to come underneath, change the divide to multiply. What I want you to do in your paper is draw me those arrows so you remember, hey, that one has to flip. Alright, so easy trinomials, I'm going to multiply for 21 and subtract for 4. So that's a x minus 7, x plus 3. Okay, because I want a negative 4, so the 7 gets the negative. Alright, on the bottom I want to multiply for 25 and add for 10. Those are going to be 5's, x minus 5 and x minus 5. Alright, now, remember this is flipping to the bottom. I want to multiply for 3 and subtract for 2. So that's going to be 3 and 1. Okay, so I want a positive 3 and a minus 1. And in the top, I want to multiply for 5 and add for 6. So that's 5 and 1 and same sign, and they're both positive. Okay. Yep, same sign, and they are not what I just wrote because they match the sign in the middle. They are both what? Negative. Sorry, I wasn't paying attention. So x minus 5, x minus 1. All right. Sorry about that. Now, let's cancel out. Looks like I ended up with an extra parenthesis on the bottom too. Okay, so remember, it's 1 from the top with 1 from the bottom. So the x plus 3's are gone. X minus 1's are gone. Okay, now be careful with the x minus 5. It's only a 1 for 1, so one of these can take out one of those, not both. So my answer is what's left on top over what's left on bottom. And then over here, we'll do the same thing, change the divide to a multiply, and I want you to do that so you remember to flip that one. Alright, x squared minus x kind of looks funny to factor. If you get stuck, it's probably GCF. You know, make sure you ask yourself, did I have one? You can take out an x, and that's at 15. Alright, this flips. The 5 is coming to the top. Can you factor x minus 1? No. So if you can't factor it, just put parentheses around it. All right, so let's knock out that. You can also knock this. What goes into both 5 and 15? 5 goes into 5 once and then 15 3 times, and that's it. So the only thing left on top is an X, and on bottom is a 3. Go practice your homework.